Hello everyone, welcome back. Today I'm going to take care of this neat Tektronix oscilloscope. The model is 222A. It is a digital storage oscilloscope and I think is dual channel, yes, dual channel. It is in unknown condition, so it might also work. It came with the original transport bag or carry bag, and I think we also have the original power supply with some adapter maybe, or just a label moved from one original power supply. I'm not sure about that. So the plan is to try to see if we can bring it back to life and see if we can add to the lab. It's not in bad condition, and it seems that everything is there. I believe here we have some adapter or maybe probe, I don't know. Okay, yeah, we have actually one probe. It's an original probe, so that is nice. And I believe the battery is behind this pouch, so let me try to remove that and see if we have the original battery in. Well, as you can see, we don't have any original battery. The original battery should have the plug for here, and here we have the cover removed. So I may try to power up with an external power supply onto the battery socket and see if we can have a working oscilloscope. Well, looking with more attention, I think that this label belongs to the battery pack. 8 volt, 2.1 amps per hour. I don't know if this is 10 hours is the recharging current. However, this is 110 line in, and this is an adapter. Well, on the schematic, there is the battery connection. The center pin is the ground, and the two external pins are positive. 9.8 volt. It is stated on the manual, so probably I will rise up slowly with the external power supply and see the result. I've checked with the ohmmeter. We are in the mega ohm range, so there is no short. I have connected the power supply. I'm at 3.4 volts, and we are drawing 20 milliamps. Must be increased, so okay. Actually, I heard something. Okay, there is too much limitation in current. Still too much. Let's see. So, okay. Now, oh, look at that. So, okay. I think there is some problem. Let's see if I can improve. I don't understand what it's doing. Seems that we don't have any vertical. AC, okay. Channel 2 AC. Don't understand what these lines are. So channel 1, it's doing something. Channel 2, it's completely non-functional, I believe. Channel 1 might also, okay, also I can hear relay clicking. Nothing on channel 2. So I think we have a problem. Yeah. Yeah, let me experiment a bit and see if I can find what the problem is. Well, I'm performing the self-calibration for channel 1. The function is recalled through the auxiliary function button. So it seems that it's doing something. Not sure if we'll pass this self-calibration. Let's wait for that. It's passed. So let's try channel 2. How can get out from here? Okay, so let's try self-calibration. Seems that I need to familiarize a bit more. Well, it seems that it can only pass the channel 1 auto calibration, and it is expectable as channel 2, even if I press ground to ground the input. We still have this sort of vertical lines, which seems related to the channel itself that is not working. So must be opened and repaired channel 2 if it is possible. Well, to remove the side covers, it must be removed the front panel first, and to remove the front panel must be removed the knobs. And I was fighting with this knob, and I discovered that must be removed the rubber cover, and that will expose the metal part of the knob with the screw. So let me remove all of those and remove the front panel so I can open it up. But that is weird. Same thing for the larger part of the knob. Must be removed the rubber part to expose the screw. So pulling out the front panel, allow me to remove the top lid. So it is exposed the inside, and I now need to trace where these are the inputs, and it seems that they are going directly into this board. So this, I believe, is the acquisition board. So let's see if I can reach the inside. Well, it seems that to reach the acquisition board must be completely disassembled. While I was doing that, I found also a chunk of the front screen down there, which is broken and cracked. So at this point I should be able to pull this out hopefully, which is this is the what they call it, the power supply board, and this is the acquisition board. So let's see if I can remove from the case. This is the acquisition board exposed with the two input hybrids. Not sure what the problem can be. By the way, this oscilloscope provides an error message through the RS232 port back in the oscilloscope itself. So probably it would be a nice idea to prepare a computer in order to communicate with that port and see which kind of error the oscilloscope give. However, I want to see if I can find anything of obvious before to prepare that setup. That's not the safest way to test, but we need to do what we need to do. So one thing that I have noted is that if I select channel 1 and I change the volt per division, I can hear the relay click. But if I switch on channel 2, there is no change in this setting. There is no clicking release, so I need to investigate the release control and circuit and see if I can find a possible culprit. Reading the manual, it seems that the complete attenuation process is done directly by the hybrid circuit, which is a floating input circuit. So I wonder if I would be able to remove and swap the two channels hybrids and see if the problem will follow the hybrid or if it's a driving problem. So let me check if I can remove the hybrid first. Okay, I've removed the hybrids, but what a scary task. I was afraid to break, was so tight in the sockets. Now I will swap the two hybrids and see if we will see some change. So with the two swapped hybrids, I still have channel 1 that is running. I have just performed the channel 2 and it has failed. So it seems that the hybrids are okay, and that is nice. By the way, this means that we have a control circuit that is not running perfectly, or actually it's faulty. Completely faulty, I would say. So let's see if channel 1 is passing. Which you see pass right now, and indeed channel 1 passes. Well, as the hybrid swapping told us that the hybrid seems to work, the approach must be more schematical. So I went ahead and studied a bit the service manual. And in the service manual there is several information beyond a troubleshooting chart. But the first information is that each channel has its own power supply with plus and minus 5.3 volts, and they are on these two channels, on these two plugs. They are okay, so that's not the problem. So at this point, I grabbed the troubleshooting flowchart, and it is requested to check the safe clock signal, which is this one. So I'm going to check on both channels that. Well, to troubleshoot this board, it's quite difficult because the majority of the ICs are below the hybrid input device. But I have found something interesting, and that would be easy to check even without the board being installed. Well, it's really difficult to make some tests on this acquisition board. By the way, I have made some comparison with the two channels, and the clock signal onto the channel number 2, and it is in pin 2 on the UCN 5895. It's always active, but in the working channel is not, and it is look at that, very active, while in the other channel, and I have checked using the ground of the relevant channel, it is only going high when it is required a change in the channel itself. So I think there is a problem in the clock generation, hopefully. Well, unfortunately, I can't do on camera the test that I have done. Let's see if I can remove this craziness of the light. Okay, so what I have is a continuous clock signal here. This is channel 2. So this is an AND port, and I have always activity here, and it is always low here. This is DAC enable for channel 2. So therefore, I always have output. Whereas in the channel 1, this is the section of channel 1, I have always activity here, but is always held high here. So I think that the problem is the DAC enable signal, which is coming from over there. Okay, DAC enable is from pin 31. So might it be this, might be control signals. Let's see if I can find any clue of that. Well, I think that I found something interesting. This is the IC that is driving the whole process, and it's receiving from the main board this signal, which is named SLDA or SLDAD2, and there is no activity. This is pin 3 on this channel, continuously high. But if I change, let me place the ground, attach it, and I check on channel 1, I have data activity. So might it be that we don't have any driving from the main board? Let's check where this signal is coming from. Before to go further ahead, I have installed back the hybrid in its place, just in case it was producing some signal So this is the working channel, and that's the faulty channel, still at high level. Okay, I don't have printed the page of the schematics that include the part of the circuit with the signal that is going to channel 2. By the way, it's through this optocoupler, and there is another one for channel 1, which is down there, this one. So both are driven through a transistor, a common transistor. So if one channel is working, it means that there is a problem with the optocoupler. So I don't know if it's a lack of power supply or it's a damaged optocoupler itself. So let's see if I can make some measure. So let's see in a different way. Non-working channel, no signal, common ground to the instrument, not the floating grounds of the two separate channels. This is the working channel, and I have a bit of activity. Clearly the level is not correct because of the wrong ground. This is the supply, this is the ground, and this is the data output, and I have my data output. Oh, by the way, I have swapped it. This is for channel 1 and that is for channel 2. On channel 2, I have my supply, I have my ground, but I don't have any data. So on the input, I have this weird data, but on the other channel, I have the same. Diode check has revealed that they are measuring exactly the same. I don't see any electronic fault. So I wonder if there is a weak connection. Maybe I can reflow the solders and see if I have any change. There might be an internal damage that the light is not passing through the base of the photo transistor. So that for sure can be a cause. I've also tried to remove the acquisition board to check if there is an overload. Nope, no output. I have removed the optocoupler and I am trying to remove the cover and see if there is any internal damage. So let's try with the tripod and having free hands. Okay, the parts are floating, so there is a lot of movement inside. Okay, yeah, nothing fancy, but let's see if I can make them working if there is any faulty parts. So these are the components that are inside the opto isolator, and let's check in diode mode. I'm afraid that I will not be able to check completely. So the emitter seems fine. You are not seeing. Let's do it again. So it seems that we have a junction in this way, nothing on the other. So yeah, the junction here, nothing there. Very difficult. With the camera on the way, it's very difficult. Okay, nothing. So the receiver, on the other hand, I have relevant to ground only one side that is reading. The other side seems open. No activity here. Well, since clearly even if I can't completely be sure that it's faulty, it seems that 99% this is the cause of the non-functioning channel. I made some experiment since it will not be easy to find these replacement parts. This is a 4N25 opto-isolator. I made this conversion sketch. It should work, but I'm not sure. Maybe that the data is inverted, so will not work the same. But at least I will see if the problem is actually the optocoupler. Then I will search for maybe another main board where to grab this replacement. Well, I have reassembled with the new opto-isolator, and now I'm having data. I'm not sure that it is correct, but it seems that at least we have some data. This is the other channel. Clearly the level is different. So let me try to make a channel, auto calibration. Well, the calibration failed, but seems that exactly the optocoupler is the faulty component. So I need to find a replacement in order to have a continuous data and correct data. I believe the one that I have installed it's not suitable for this. Well, I have swapped the optocoupler, and I'm currently doing the auto calibration on channel 2, and it seems that actually it's working. So the replacement of the optocoupler with the 4N25 didn't get the expected result. And looking at the behavior, I am confident that it will pass. Let's see, we are close. Yeah. And indeed, channel 2 passes. Let's see. Again, channel 1 off, channel 2 AC, and it's now clicking. So that clearly it's encouraging. However, I now have the trace. So the channel is fully working, and of course channel 1 it doesn't work as yeah, there is that strange behavior. We may try to perform the auto calibration, but I'm pretty sure that will fail. And indeed, we don't have any trace there. So we need to repair the optocoupler or to find a replacement. When I was struggling to find a replacement, I did find a main board, but very expensive. and don't wanna invest so much money just for an optic coupler. So I eventually came across onto the original board, but the non-A version, so is the 222. And it's happened that it's used this kind of optocoupler, and there are three versions. There is the L1, look at that, okay, and there is the L2 and L3. So I made a quick drawing just to make a cross-reference of the pinout, and it seems that I can only need to swap those two. Sorry. So I prepared this socket with the crossed terminals over there. Let's see if it works. And this is the type L1 installed. Hopefully it will not hit in any place, so it should match the original configuration. Let's see if this kind of optocoupler works. It seems that we need to find a different solution, as it's touching the CRT and it's not able to go down in place. But for testing purpose, I will leave like that. So I have connected the bench power supply. Let's see if we will have both channels. So let's enabling the output. It is powering up. Oh, look at that. We indeed have two lines. Okay, so channel 2 is now moving, as well as channel 1. So I think now we just need to make a different connection, but we are back in business, and probably will be in need of calibration, but yeah, it's fixed. I'm really happy about that. I was not expecting to be able to solve this problem, and just by looking at the original 222 non-A motherboard, I was able to find a replacement, a cross-reference. That's really nice. I'm just trying to perform the self-calibration of channel 2. Quite long process. Dots, it's nice. It's passed. Well, there is another thing to test, which is the clicking of relay, which indeed we have on both channels. So both channels seems to work. So need to fix the problem of the high of this setup, and then we can reassemble it. Well, I have lowered the socket by trimming all the extension that I have done to the legs, and I've also pushed it be more far away from this socket. So let's try if it is fitting now. Well, we should have enough room now. It's not easy to check right now, but centering to the front panel seems fine to me. Well, I've reassembled the oscilloscope and let it warm up for about half an hour, and I'm going to make the calibration, And we already see that we have an Nix wider amplification than it should. This I think should be within the graticle. So let's go ahead with that. Well, in order to calibrate the trigger, I had to dismantle the front panel. And to be sure that it's working fine with the sweep measurements, I'm applying a time mark generator, and it is seems a bit too high. So let me reduce a bit. And then change the position. Still too high. That is spot on. Wonderful. Calibration finished. Well, as you can see, I had to completely dismantle the oscilloscope again, just because I forgot to install the input circuit with its shield. I believe this varnish is conductive varnish and act as a shield. So probably this will have also a small impact in the calibration. So I will reperform the vertical amplifiers calibration. Well, luckily it barely fits the optocoupler arrangement that I've done. So we are lucky with that. And check again the self-calibration. The channel 1 has just passed. So let's see channel 2. This should be the end of channel 2. Dots should be fine. And yes, it has passed. So I think at this point we should be good to go. And this is the finished oscilloscope. The scope is working fine, and I'm pretty happy with that, and pretty happy that I found this solution. Unfortunately, there is a huge crack in the CRT screen, and it was already cracked a bit, but as I have touched it, it has split in 3 pieces, probably because of the impact that I have received in the past. Now, the only one probe that I have is the original P400, which is quite rare to find. There are some way to modify the input and use a regular scope probe, but I don't like to perform that modify with BNCs, and moreover, the regular probes can reach only 300 DC volt, and the original one, it's almost 1.5 K, so there is a huge difference. Now, the reason why I want to have this fully working, it's because I want to troubleshoot high efficiency power supplies of 700 and 7000 series oscilloscope. I have a bunch of oscilloscope that are not working because of the power supply failure. And this being completely isolated, it will be the perfect instrument to make signal testing onto the primary section of the switching power supply. So probably I will prepare a nickel manganese battery pack, and I will go from there. And yeah, I think that's it for this repair. Hope you have enjoyed it, and I hope to see you in the next video.